Hello, everybody. Let's do a quick mic check here before we get any further in. Oh, yeah, we're looking great today. Oh, but our hair's not. Let's fix that. There we go. Much better. Whew. Hope everybody's having a good night. We've got about 3.5 minutes left until we get started. Let's go ahead and do what we normally do. Take a look at the leaderboard, personal stats. Yesterday we got 2,300 and then like 1,900. So not great for us, but sick improvement from the first to the second one, which makes sense. We wrote a good solution for the first part. And if we take a look at the private leaderboards and see the work one, Brian Kendall is caught all the way back up. Fascinating. And Kevin Chung actually not far behind. He's missing 1 star from 2 days ago and from 3 days ago, and he's missing both stars from 2 days ago. And Puff has just missed the last 2 days, so we'll probably catch up. No Hey Dev, probably out of the race at this point, but he could certainly catch up. He's only 5 problems behind. That's, I don't know, a couple hours worth of work. And if we check the other one, no one has surprised me at all. I think Ryan's now actually that's not even Ryan. Sanj Guna is a full week behind, and Ryan's more than that. He's 9 days at this point, so this is basically just me all by myself, which is fair enough. I have good news for you, by the way. I did, in fact, win my fantasy football game, which I think I told you guys last time. So now if we go to, where is it? League schedule, and we look at this is the whole schedule. Where is it? Yes, the playoff bracket. I am in the playoff bracket, playing the same person that I played last week. So that should be actually a pretty good matchup. I think it's projected relatively close, but I think I'm projected to win. I actually won both of our matchups. Fascinating. And I needed to in order to get in the playoffs. It looks like right now I'm favored by about 17, which I'll take, and I think my opponent has some changes to make in order to get the real projection, but no real complaints there. So that's nice. Looking forward to that. Yeah. Feeling a little less drained, a little more focused today. Excited to sit down and be doing the work, and hopefully that'll result in a slightly better result tonight. But no qualms if it doesn't. I'm actually not that worried about it. We do, however, we do. And I'm also excited. I think tomorrow I'm going to take the day off. So after we get this done, I'm going to put that in for work and see whether or not I can get a tea time tomorrow and wake up and go golfing. That'll be fun. Hopefully I can play by myself, but that's never really how it works in some of these courses. That's all right. We'll see who I'm playing with and figure it out from there. Bring some headphones, relax, have a good time. Try not to stress out too much. Play until I don't feel like playing anymore, and then call it. I haven't been very good at golf lately, or ever. I mean, I've only been learning for the last couple months, but the most recent day that I had was not so great, except for the last hole where I scored a par, which might have been my only par of the day. Let me go look. I would show you this, but it's in a Facebook chat, so I can't really. Here we go. This is a way that I can show it, though. Nope. This is, we're too zoomed in here. Yeah, so if we see, this one's me. Yeah, I got a par here. Nothing. One, like a bogey. Again, I play pretty poorly. This is also another bogey. This is also another bogey. This is a par. Okay, I got 2 pars. Okay, not terrible. So we take that. Oh, and here's 14, right on time. Day 14, Regolith Reservoir, or Regolith. The distress signal leads you to a giant waterfall. Actually, hang on. The signal seems like it's coming from the waterfall itself, and that doesn't make any sense. However, you do notice a little path that leads behind the waterfall. Correction, the distress signal leads you behind a giant waterfall. There seems to be a large cave system here, and the signal definitely leads further inside. As you begin to make your way deeper underground, you feel the ground rumble for a moment. Sand begins pouring into the cave. If you don't quickly figure out where the sand is going, you could quickly become trapped. Fortunately, your familiarity with analyzing the path of falling material will come in handy here. You scan a 2-dimensional vertical slice of the cave above you, your puzzle input, and discover that it is mostly air with structures made of rock. Your scan traces the path of each solid rock structure that reports the XY coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. Each path appears as a single line of text in your scan. After the first point of each path, each point indicates the end of a straight horizontal or vertical line to be drawn from the previous point. For example, 498.4, 498.6, 496.6. This again means that there are two paths of rock. The first path consists of two straight lines, and the second path consists of three straight lines. Specifically, the first path consists of a line of rock from there to there to there, and another line of rock from there. Wonderful. The sand is pouring into the cave from point 500, 0. Drawing rock as hash and air as dot, and the source of the sand is plus, this becomes this. Sand is produced 1 unit at a time, and the next unit of sand is not produced until the previous unit of sand comes to rest. A unit of sand is large enough to fill 1 tile of air in your scan. A unit of sand always falls down 1 step if possible. If the tile immediately below is blocked by sand or rock, the unit of sand attempts instead to move diagonally 1 step down and to the left. If that tile is blocked, the unit of sand attempts instead to move diagonally 1 step down and to the right. The sand keeps moving as long as it is able to do so. At each step, trying to move down, and then down left, and then down right. If all 3 possible destinations are blocked, the unit of sand comes to a rest, and no longer moves. At which point, the next unit of sand is created back at the source. So, drawing sand that has come to a rest as O, the first unit of sand simply falls straight down and then stops. The second unit of sand falls down, lands on the first one, comes to rest to its left. A total of 5 will come to rest like this. A total of 22 look like this. Finally, only 2 more units of sand can possibly come to rest. There and there. Once all 24 units of sand have come to rest, all further sand flows out the bottom, falling into an endless void. Just for fun, the path any new sand takes before falling forever is shown here with a tilde. Tilde, blah, blah, blah. Using your scan, simulate the falling sand. How many units of sand come to rest before sand starts flowing into the abyss below? Okay, let's get our puzzle input. That's long. Okay. Oh, and there's numbers above 500. That's kind of annoying. So X is... let's go back to the top. It says X represents distance to the right and Y represents distance down. And we start at 500, 0. Cool. So the Y coordinates, we can do whatever we want. The X coordinates, just 500 is the center. So we want, looks like all these X coordinates, like if we start with like a 6, does anything start with a 6? Like if we look, space 6, there's nothing. What about space 4? There should be a lot of space 4s, like to the left. Only a couple, actually. They're almost all to the right, which is interesting. Cool. And then the Y coordinates go down, so we're cool there. So, if we look here at like 599 or something, we don't find it. 590, 59, 59. We know 544 is there. What about 550, 560? No, that's just 56. 567. 570? Okay. So basically we want an array of width like... Let's call it width 1,000. We want to read... Here, let's... Well, we can copy in the smaller ones. So... What do we want here? Boolean grid equals new Boolean, and then it's X and Y. So X needs to be 1,000 and Y needs to be, so comma 1, there's definitely that, comma 2, it's only comma 23. Yeah, huh. And so then the distance down has to be like 200-ish. That should be good enough. And in fact, why don't we make these variables int width equals, here we can make these static. Private static final int width equals 1,000. And let's copy and paste this, and we're gonna go height equals 200. Now we can just go width, height. What are we upset about? Oh, and it's just mad because I had this line. Cool, so we're good there. While scanner not has next line, then we want string line equals scanner dot next line, string lines equals line dot split that, and then we should be good. And then for string, oh, it's not quite, we need like pairs of them. For int I equals 0, I is less than lines dot length minus 1 plus plus I. And then we want to like have something that like, we want like fill in line segment or something. Sure. Let's do that. Fill in segment lines I plus 1. And I think we want to put the grid first. Cool. So let's private static void fill in segment boolean grid string first point string second point. Int start x equals we want like first point dot split on comma got get 0, and we want to integer dot parse into this. Parse into this. Start y is the same thing but 1, and then we want end x equals this, but it's second point. This should also be second point. This will be 1, and this will be end y. We don't know. There's actually nothing to copy there. And so we expect that either start x or do they have to be? 1 second. Let's read this. Your scan shows past a solid rock and reports the xy coordinates that form the shape of the path, where x represents the distance to the right and y represents the distance down. Each path appears as a single line of text in your scan after the first point of each path. Each point indicates the end of a straight horizontal or vertical line. They are horizontal or vertical. So if start x equals start y, then for int I equals, just not start x equals start y, start x equals end x, start y, I is less than or equal to end y plus plus I, grid, and then what do we want to call it? Grid start x I equals true. Now we just want to do the same thing with it's actually just else. We don't have to do anything fancier than that. And this should be start x. This should be end x, and we want I start y equals true. And then that'll be it. That'll fill in a segment. That should be good. This will fill in all of the segments. So now we should be fine. So now what we want to do is we want to simulate, and then we want to see int count equals 0. While true, something 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 plus plus count. If not, insert lands in insert and return if lands in grid, takes in the grid, break number of grains plus count, and let's make count grain count. Wonderful. So now we just need this. Private static boolean boolean grid. Cool. So now we just need to insert a grain of sand if we can. So it's going to start int x equals 500, int y equals 0. So while true, if grid x y is false, so it actually should be, let's see, it should be x y minus 1 equals false, y equals y minus 1. We're going to make these lowercase. Shift F6 x. Oh, nope. Shift F6 y. There we go. Else if grid x minus 1 y minus 1 is false, x minus equals 1, y minus equals 1. We're just going to minus equals this actually, because that looks better. Else if, and the same thing, but x goes to the right. We're just trying to see if we can traverse down right now. Then x plus equals 1, y plus equals 1. We're gonna have to hope that the width and the height that we have is sufficient for this. It should be. Else, so if we reach this place, then grid x y equals true, return true. And we need another conditional here. If y equals grid dot length minus 1, should be grid 0 dot length. Return false. Is that right? If we get all the way down to the y's, we just assume that we're done, and we made it larger than it is because again, there's a bunch of these, and if we check for 200, there's nothing. We check for 100. Oh no, we need comma 1. Yeah, there's plenty of this. Plus 190. No, it's just 119. 150. Yeah, 160. Yeah, 170. Yeah, 180. There's nothing. Okay, so that should be fine. So if we get to the bottom of the grid, just we couldn't insert, it's just gonna fall out. Otherwise we go through, and then when we get to the current point, it's either gonna go down 1, or it's gonna go down 1 to the left, or it's gonna go down 1 to the right, or else it's just gonna return true. Cool. So this in theory should work. Let's give it a shot, and it's gonna get mad because there's nothing in the scanner. Yeah, that array index out of bounds. Well, that also makes sense. Yeah, take me to here. Next. Oh, this needs to be a plus. Okay, all right, because we're going down. That makes sense. Plus. So all that's right. And then if y equals, yeah, and we're incrementing, so that's great. And let's put in the test data and see what we get. Put in the test data, run. Number of grains is 0. That's not correct. Let's see what's going on. Okay, time to debug. So let's go here, debug, and we'll watch what happens. Cool. So we got a scanner, got a grid, got a line. We have 3 things here. We should have a thing of 3 elements, so it should be less than line next one of 1. That's correct. So now we want to fill in segment for 498.4 and 498.6. And if we look at grid, are there a couple of trues there? Here, let's evaluate actually. So if we go grid 498.4, true, 5, true, 6, true, 7, false, 3, false. Wonderful. So that appears to have worked. And if we go down again, and if we step in real quick, get these, so now it should go down. So that should be fine. Take me back up. And then we're done. Great. Scanner has another line. Insert another thing, please. Cool. Insert. Line grid. So X is 500, Y is 0. We should just let's make this the conditional. While Y is less than grid.length. -1. And then when we get out of the while, we can just return false. This is gonna do better for us. It's just gonna read better. Okay, let's stop and rerun, and we can get back to this point pretty quickly. Go down, yes, fill in the line segments, nothing has changed. Let's go here. Yes, go again, wonderful. Yep, you better believe it. Grain count, so we're 500, 0. That's true. So grid X, Y plus 1 is false, Y plus equals 1. 1, and let's look at the thing. So it's gonna fall straight down until it gets to here. 2, which is at 0, 1, 2, 3, 4, 5, 6, 7, 8. 5, 6, 7, 8. 9, 10. What's going on? Do we not? Okay, let's look at grid 500. And then what is the one that should get us there? Let's look at this. Nine? Why is this false? Okay, let's stop and debug. Clearly something's wrong in the way that we're parsing that stuff. Oh, it's because we're assuming that the numbers increase. Got it. This should be math.min start y and y. Math.max start y and y. And we need to do this same thing, but for .min start x and x, because the line segments can go in any direction. Math.max start x and x. Wonderful. Okay, we're a genius. Now what if we do this? Stop and rerun. 24. Is that the right answer? That is the right answer. Let's put it in on our big input now. See what we get. That's a lot of lines. This is going to take a second. 698. Apparently not. That's the right answer. 712. Wow. Okay, top 1,000. You realize you misread the scan. This isn't an endless void at the bottom of the scan. There's floor, and you're standing on it. You don't have time to scan the floor, so assume the floor is an infinite horizontal line with a y-coordinate equal to 2 plus the highest y-coordinate of any point in your scan. An example above, the highest y-coordinate of any point is 9, and so the floor is at y equals 11. This is as if your scan contained one extra rock path, like minus infinity, 11, infinity. With the added floor, the example above now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until the unit of sand comes to rest at 500, 0, blocking the source entirely and stopping the flow of sand into the cave. In the example above, the situation finally looks like this after 93 units of sand have come to the rest. Using the scan, simulate the falling sand until the source of sand becomes blocked. How many units of sand come to rest? Okay, well, it's a good thing we made our stuff super wide. And then the other thing is, we don't really have to change much. Let's see. So if we go to comma 168, 169, there's nothing. 168, so 170. So now we want to insert, let's copy part 1. And we can paste it into part 2, and we'll rearrange these in a little bit. And so now, in fact, we're going to rearrange these now, because I need to be able to go down to see functions and something ordering of stuff that happens. Okay, great. So we read it in, and then we want to go fill in segment grid, and then we want 0, comma 170. Then we want 999, comma 170. That seems like it should be right. So now we want and so it's asking us how many units until the sand comes to rest. And so we also want to return false. Yeah, so now we can also if grid x, y, true, return false. Cool. So that should do it. It'll still count correctly. So that should do it for part 2, I think. Part 2. Cool. 27,267. Let's see if that's right. Not the right answer. Return to day 4. Let's see if does that come out right? Is that good enough? Let's look at this picture and figure out how wide this could be, because it gets wider than you would think it should get. Like the fact that this is so wide is kind of weird. Not entirely, I guess. So yeah, it kind of does some of this. It can get real wide though. Because let's think. Like how does it get? Okay, so then it falls here, and then there is the space down, right? So when you form this, then you're going to start to form a wider thing. So it's going to be like 1, 3, 5, 7. So 107. Okay. Okay, so it should be 93 units for that. So let's try the test data again. This, and then this floor would be at, it tells us 11. So instead of this, 11. So let's try part 2 now, see if we get the right thing or if we're off by 1. 93, okay. Great. So did we get the thing wrong? Comma 17. 17. Oh, it's because we're too high. 172. 72. No, 172. 173. 174. 175. 176. 180. 190. Okay, 178, 7, 9, 6, 5, 4, 3, 2. 172. So it should be 174. That's what we screwed up. So 174. 174. There we go. So put all the input in. This is what we get for not programmatically determining this, but you know what? Screw it. 28,594. We did it. We got rank 771. Oh, 2 top 1,000 finishes. Look at us. All right, let's begin the process. But let's look at the stars leaderboard. I mean, I'm not anywhere close. Took these people. The fastest person, it took 4 minutes and 53 seconds. That is hilarious. And the same person got the full puzzle in 5:56. That's wild. But yeah, a lot of these people. Good for them. So 1354 would have gotten me there. And if I go to my personal stats, okay, so took me a little longer than it would have otherwise, but that's okay. And this part literally took 4 extra minutes because I'm dumb. All right, okay, let's look at our leaderboards here, see if anybody got there. I mean, do this. Yeah, nobody's even tried today yet. And if we go to our other one, of course, nobody's tried anything yet. Okay, we still like checking every day though. All right, let's copy this over and begin. Put in the problem statement. And let's go. All right, this comes at the top. Oh, come on. Escape. There we go. He's behind the waterfall. Correction, blah, 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 blah. Rock. Your scan. Port stuff in XY coordinates that form the shape of the path, where X represents the distance to the right and Y represents the distance down. That should be it. For example, this game means the 2 paths of rock, blah, 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 blah. .4 through 498.6. Another line of rock from 498.6 through 496.6. Sand in the cave is pouring for 500.0. Drawing a rock as this, air as this, and sand as plus. Oh man, okay, we're doing okay. All right, cool. Just got to make sure the microphone's close enough. We have this. For some reason, they put an extra space at the top, and so will I. Wonderful. Sand is produced 1 unit at a time. And the next unit of sand, something, 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 come to rest. Let's see. Down 1 step. 1 step and down to the left. 1 step down and, oh, nope, go back to the left. If that tile is blocked, I'm gonna go ahead and guess that 1 step down and to the right is bolded, and we'll see if I'm right. Oh, he's right. And then once they're blocked, the inner sand comes to rest. It would have been fun to do this in 3D. I mean, it would have been tedious, but still, it would have been an interesting problem to solve. Second unit of sand, something. So a total of 5 units of sand. Pattern. So 22 total units of sand. Finally, only 2 more units of sand possibly come to rest. 24. Oh, nope. Nope, not what I wanted. We're gonna do this, then we're gonna do this, we're gonna do that, and we're gonna do this. Not exactly what I wanted, but we can fix that. Something about tildes, wonderful. Here we go, we've got these nice beautiful drawings, we're making progress. How many units? Nice. Puzzle answer was 698. Part 2. That's the scan. 2 plus the highest Y coordinate. It needs to be bolded, and Y needs to be put in code. So does this Y. Glad we caught that. Example above, oh man, gross. Highest Y coordinate of anything is 9, so the floor is horizontal at Y equals 11. It's an extra rock path, like minus infinity to infinity 11. That at floor, example now looks like this. To find somewhere safe to stand, you'll need to simulate falling sand until something comes to a rest at 500 0. 93 units. This needs to be bolded as well. So again, to simulate how many units of sand come to rest. Your puzzle answer was this. Wonderful. Okay. Here we go. Read in grid of line segments. Late grains of sand falling and count them. And the same is true here, basically, because we did such a good job encapsulating our functionality. Insert floor to below the lowest line segment point. Wonderful. This fills in a line segment from the first point to the second point in grid. Wonderful. Simulates a grain of sand falling starting at point 500 0 when the grain of sand comes to rest, or it inserts it and returns true. If the grain of sand would fall off the bottom of the grid, or the entrance point is already blocked, return false as a sentinel value. Okay, I think it's time for our explanation. So, as shown here, you have an endpoint, and then you have some rock shapes. And so what you do is you simulate sand falling. So the first grain goes all the way down, each subsequent grain goes down, and if it's blocked straight below, it'll fall down and to the left, then it'll fall down and to the right, and so on and so forth. And so we want to simulate sand filling up. And for the first part, we stop simulating sand when everything would like fall off the end here, like this set of tildes. And so the way we do that is first we read in the line segments that are given as our input, and we fill in the grid with trues for there, and then we simulate grains of sand falling. So we start at 500 0. Hey baby Yoda Sensei, good to see you. Oh, and you subscribed. That's really kind of you. I appreciate that. I don't have alerts on right now because I'm doing some coding stuff. So what we do is we check the point directly below us, then we check the point below and to the left, then we check the point below and to the right, and then if none of those points are free, then instead we just insert where we are and we return true. If the entrance is plugged up, then we return false, and if we run off the bottom of the grid, which is what the while condition is, we also return false. And so we basically just keep doing this, and we count how many grains of sand go through, and then we print that out when this returns false, we break. For part 2, it's slightly more complicated. We insert a floor just below all of the line segments, and then we simulate all of the sand falling and count it up, which is basically exactly the same process, except we have to add in a floor segment, and then in our conditional here, we need to see whether or not this initial point is blocked up, and if it is, then we just immediately return false so that we can stop simulating. So that's all today's was, just a straightforward simulation problem. I'm sure there's some math you could do to get the answer a little bit faster. Actually, I'm not sure that that's the case. I think this just straight up simulating it might be the fastest way to do this. Perhaps there are some tricks you can do so that you don't have to simulate every grain of sand individually. But this ran in, I don't know, 2 or 3 seconds, so relatively easy. Anyways, I think that's all I have for you folks tonight. Baby Yoda Sensei, I am doing Advent of Code, which is a programming competition every night at 9 p.m. And I've been uploading the VODs here if you want to catch up. If programming is not your thing, that's totally fine. Well, I should say segments and not segments. So feel free to go check out how we're doing on YouTube, where I've been uploading all of these VODs. Gotten a lot of views, not a lot of traction in terms of watch time, but that's okay. These are not the most exciting VODs in the world. It's just a man sitting there and programming. Though if you like listening to some dude just sort of babble on about whatever while listening to chill music, this is definitely your vibe. Other than that, I think that's all I've got tonight. So let's go ahead and commit this real quick. Day 14 solution, including documentation. Commit and push. You can find all of my previous solutions on GitHub. Yeah, absolutely. I'm going to get back to chess content sometime soon. I'm still publishing stuff on YouTube every day for that, or every Thursday and Sunday for that. But for right now, just for the month of December, most of my streaming is going to be programming stuff, because that's how the cookie crumbles. Actually, give me a minute. I would. First of all, let me sign off. I need to take about a 2-minute break, and then I'll come back and actually play some chess on stream. BRB.